Okay, so we are doing the lab on standing waves and air and string. You should have a copy of the lab so that you can fill in the answers. On the second page of the lab, there is a place to input our data. The very first blank says, locate the packet string 10 meters long and record its length. Well, duh, the length is 10.0 meters. So you need to write 10.0 meters in the first blank. The second line says to take the string out and of the plastic bag and put it on the scale. And so we will, here is our 10-meter spool of thread, and I'm going to put it on the scale and turn the scale on. Well, maybe I will and maybe I won't. Let's make sure it's 0. All right, I'm moving the camera so that you can see the data. And so we have our little, ooh, I'm too close, aren't I? So the camera doesn't work very well this close, but you can see it says 0. I'll put the string in the middle. And you need to record the number, remembering that it has a single decimal point located right here between the 2 digits, and that we're in grams. So it's between the 2 digits and we're in grams. All right, back where so we have the mass of the string. It's 10 meters long. I'm gonna put it back in the bag. That means you are ready to do this first calculation, which says to calculate the linear mass density. The formula for that is on the very first page of the lab. You will see equation 2 is the linear mass density equation. So you want to use it. If you want to calculate things, you can pause the video and resume after you've got that done. But I'm going to move along with my video. So step 4 says one end of the string is attached to a pole and the other to a pulley and a weight hanger. This is the weight, and I'm going to hang it over to pull the string tight. So I'm connecting this to the string. So here's my little loop of string. It's the same kind of string that we just weighed. You can see, I'll put it over my pulley. And now we need to know the length between the top of the pulley and the knot in the string. And so for that, I have a tape measure that measures in both inches and centimeters. I'm going to set it up so it will go the whole distance. And then I'll videotape so you can actually read the number. Okay, I know this is a little awkward because I'm out of frame, and I think I must have picked the world's worst tape measure because it's not giving me a good number. It wants to slide back. The number is fine, but what's wonky with it is whoops, almost there. This is easier with 2 people, but I don't have 2 people. It's just you and me. Okay, camera's moving. We're gonna come over here. And hopefully you can read. So we're on the scale that's centimeters, and you want to read to the knot. The string is tied. I don't know if I can move away and get it so it's a little bit more glare free. Probably not. You just want to do your very, that's That's much better, in fact. So the bottom set of numbers are in centimeters. You want to read those to the best of your ability to the knot. The little piece of string is hanging down right at the knot. All right, you should have a chance to have gotten that number in place. So that, again, okay. So that particular number is going to be our lambda, our wavelength. It'll go right here in the lab itself. So step 5 says to place the hanger on the string. We did that. It says to turn on the frequency generator. So it makes kind of a low hum. Maybe you can hear that. And what we need to do is adjust. What this is doing is a speaker. I'm going to move this so you can see it. Flips under the string and around we go. I know, it's enough to make a person dizzy. So you can see I've got the speaker connected so that it, as it goes up and down, you can maybe see it's making the string vibrate. If I turn it off, you can see there's a difference. Well, what we want to do is we want it to vibrate, but we want to get 2 loops. And so I need to adjust my frequency. Right now, it is on 100 hertz. And that appears to be too much because I've got 1, 2, 3, 4 very, very small loops. And we want 2 big loops. So I'm going to come down. Ooh, okay. One thing you should notice is that the vibration amplitude has gotten significantly larger. And I've got 1 loop, and this one is 2. And whoops, way down here. And we see it is 3. So that's loop 3. This is loop 2. And here we have loop 1. So that's 3 loops, but I only want 2. So we have to keep going. You can see that for our 3 loops, we're at 81 hertz. So let's keep moving, see if I can make it vibrate larger and have fewer loops. That is actually looking pretty good. I want to fine tune it. All right, that just made it shorter, and we don't want shorter, we want taller. Oh, there we go. Let's shorter again. So back it up, back it up. That might be about it. So as you can see, for 2 loops, this is our frequency in hertz. And you can perhaps see, so we have, oops, there we are. We have 1 loop here. And this is an anti-node where it's not vibrating at all. And then we have our second loop over here. And you can see, I can touch it. Funny things happen. All right, so we have our loops, we have our frequency, we are almost done. All we have to do now is not get dizzy from the camera. I'm very sorry about that. All we have to do now is find the mass of the weight hanger and its load. So we have this. By the way, the number, the red number we read off the box would go in the blank right here. The red number we read off the box will go right there. All right, so step 6 says to do some calculating, which you can certainly stop the video and calculate. Step 8, I don't know why I jumped from 6 to 8. Who knows what happened to 7? It's a typo on my part. But the very last thing on this page is to find the mass of the weight hanger and its load. So we have to put this on the scale. I'm going to turn on the digital scale again, have it go to 0, and then I'm going to move the camera so that hopefully you can read the number. That's not too bad. And remember, the very last digit is to the right of the decimal, and that this is an answer in grams. So the very last digit is to the right of the decimal place, and that our number is in grams. So there's a, so there's 3 digits to the left of the decimal, 1 digit to the right of the decimal. All right, stop. Going back. So again, the number off the scale goes right here, bottom of page 2. If we flip just to make sure, so page 3 at the top, you have a calculation, you have a calculation and a calculation, and then you're done. So the lab didn't take very long. It is way more fun in person, but this is better than nothing.